Hello, Make Trailers. I have made the most advanced computer in the game. This is the DLA3 Lunch Computer. It is complete with an 11-function ALU that allows it to do addition, subtraction, multiplication, division, equals, less than, greater than, and, or, XOR, and NOR functions. It has 16 bytes of RAM, so it can store up to 16 numbers at one time. It has a 6x6 screen, and it can address each pixel individually, so you can draw anything you want as long as it fits on a 6x6 screen. And above that, there is a number display for in case you want to display numbers that you are using in the computer. It has a Wi-Fi 1.0 port. I'll get to that more later. And it has a 6-bit serial device port, so you can plug in external devices here so the computer can use them. And finally, it has an data card. App cards are for the DL series. This uses data cards. And these data cards are in charge of holding the programs. This is a 64-byte data card. So this can store up to 64 bytes of program data. And so you just plug this into the computer, right here into this port. And now the computer can read those programs and run them. This one should be blank, but I do have other ones, like this draws a smiley face on the screen. The computer can run up to 21 different commands, and I'll leave a link to the command sheet in the description. So to run your program, you get into the computer and you press space. You can see it jump into action. This will take a while, so I'm going to fast forward. Ta-da! Smiley face. Now, moving on to Wi-Fi. This computer is the first device to use Wi-Fi in Trailmakers. To use Wi-Fi, you get this big antenna, which can send and receive 8-bit data, and you plug it into this port. And it's got little pistons with anchor pins on the sides, so you can lock it in place so it doesn't move around. Then you go to wherever you want to put the receiver, the receiving device. These antennae work up to 200 meters, and you just plop that down, and you plug in a second antenna. Now these antennae will auto-pair. As you can see, it is slowly moving clockwise, but you can use A and D to move the antenna manually to save a little bit of time. After you get it close, I would recommend you just let it do the rest itself, so it can do it reliably. Once the antenna sees another antenna, or object in general, it will send this code, 101000101. Once it receives this code for 5 seconds, it acknowledges that it is paired, and the indicator light turns to green, showing that it is paired. It does this so that it doesn't accidentally pair to some other random build, and ensures that it is pairing to another antenna. This right here is a test card, so it only has 4 bytes of program data, so that I can just test quick little parts of the computer whenever I need to. This will send the number 7 over Wi-Fi. So we get in here and press space to start it, and we let it do its magic. Ta-da! The neat thing about this port right here is that it doesn't have to be Wi-Fi. You can send whatever data you want through that port, so you could even hook up another screen to it that's bigger. Like this, I have this meant for graphing, so whenever it receives a number, it will input it onto the screen, and then it will increase to the next row, so it's ready to input another number. If you want to use the device port, you will need to use this decoder though, or a decoder on your own build. And this decoder takes the 6-bit serial, so that means it's all in a line. It uses 2 pistons to communicate 6 bits instead of the usual 6 pistons. So in this, all this does is turns those 2-piston encoded data into 6-piston output. I had to do this because I was limited on complexity, and I needed some way to make this while keeping it under the complexity limit. And since pistons take 20 complexity each, this was the best way to do that. I have this test card yet again set up to send data. Instead of sending the number 7 to this port, it will send it to this port. And so now we watch it do its magic. As you can see, it put it out in 3 short bursts to fill up the slots 1, 2, and 3, which is the number 7 in binary. And then this will output it. I just realized that is backwards. I'll fix that. There are also special editions of the DLA3, like the DLA3M and the DLA3I. The DLA3M has 6 additional math functions: square, square root, sine, cosine, tangent, and random. And it does not have the device port to save complexity. Instead of a screen, it has a number display. Other than that, it works almost exactly the same as a standard version. The DLA3I works very similarly to DLA3. Almost all the hardware is the same, except it operates on around 7 to 8 Hz instead of 1, and it has built-in ROM instead of having a data card port. That mostly sums up the DLA3 logic computer, the most advanced computer in the game as of this video's release. Thanks for watching. Have a good one.